About 3 months ago, I finished my IGCSE exams, and one of the subjects that I took was computer science. So, IGCSE computer science was separated into theory and a practical section. And in the practical section, we were made to code with Python. Python is a really good programming language for beginners, and it's also good for making video games, mostly 2D. In fact, I took some time to simulate gravity between particles in 2D. It did come out kinda nice, but the thing is, I really want to make one in 3D. And Python isn't exactly the best coding language to get things like that done in. So, I decided to install Unity and code a 3D version of my gravity simulation using C Sharp. And let me tell you, I spent copious amounts of time just installing Unity. Well, without any more yapping, let's get started. Okay. Something installed. Yeah, okay. Okay, I just finished verifying everything. Open Unity Hub. It's already open though, so I don't know what it's gonna do. Oh, okay, it's signing in. Get Unity Personal. You need an active license to use Unity. Wait, does that cost money? Does Unity license cost money? Yes, Unity license can cost money. They also offer a free option. Okay, I'm assuming that's what I have right here, so I'm just gonna agree to it. Why does it fail? Editor application download failed, validation failed, but it's still downloading something.
So I will forward the video to where it is done, so you don't have to watch the whole thing.
Okay, I haven't even gotten the downloading thing, and it's failed. Download failed, validation failed. What does that mean? Unity Hub download failed. Okay. Okay, what is this saying? Okay, so I'm assuming. Red install. Okay, moment of truth. Oh, it's doing something. Okay, it's installing everything. Well, I guess that really won't take too long. Never mind, my internet speed is in the kilobytes per second. Actually, this might take a long time. So, what I'm going to do is, I'm just gonna do this. Okay, so after a while, the progress bar disappeared. I don't know what that means. That probably means most of it's done installing, but I don't know. With my internet, it's probably not installed. So I don't know what this is gonna do. I probably have to wait a bit more, actually. So, back to this, I guess. Okay, it's gone on for too long now. I don't know what it's doing, but I tried to figure out why this happens. So, how long does edit application it install Unity Hub? Wait, something just opened. Wait, something actually. Oh, it just finished. What? Before you get started, we need to set up a. Is it actually trying to install? Okay. Oh, okay. Now it's speeding through it. Okay. Okay, I guess that's good. Okay, so something appeared. How much does this increase the storage? Oh, okay. No, we are not getting this. What about this? Never mind. Okay. We're just installing this. I'm not going to do anything. Game development in Unity. Is that actually a workload in here? Oh, it is. Wait. Okay. That's important. And install. 3 gigabytes now though, so well, I guess you know what I'm gonna do. Yep. Okay, wait, how much has it downloaded? Oh, okay, it literally just... Okay, no, I don't want to start after installation, that's not good. And it's done. Oh, that's good. Now that that's installed, I think we can just create a project. We don't have to select it, right? Yeah, it's just there, okay. Create a new project. Editor version, okay, that's where you select it from. Essentials, pathway, 2D platform, micro game, fun. Yeah, fun. Okay. I don't know what this does. I don't know what that does. I'm just gonna leave it. Okay. And this is going to take forever too, isn't it? Yeah, it's going to. Well, yeah, back to this, I guess. Oh, iron. Okay, so small update. The night I installed Unity, I didn't really feel like continuing because it was already getting late. So I waited 2 days. I don't know why I waited 2 days. I just had a lot of random stuff going on. But I guess I'm going to start Unity today itself. And let's see what we can get done. I sort of remember this. I think you can... Yeah, the controls feel somewhat similar to Blender. You have the axis and a bunch of stuff here, I think, that plays things. The objects which get highlighted, that's also good. What's a global volume? Wait, wasn't there a key to zoom in on object? Oh yeah, it was F. So before I actually start anything, I want to set some goals that I want to achieve by the end of this video. So obviously I can't really learn everything in Unity in one video, so I'll break it up into multiple videos. But in this video, I just want a working environment with an object that can interact with other objects by gravity. So the simplest thing to do is maybe make a small environment with 2 spheres, and the spheres can interact with each other as if they have gravity, like planets. And that's basically what I'm going to start with. And in the next video, maybe I'll add textures, then work on lighting. Maybe I'll even add a character who can go from that planet to the next planet. Something like that. Anything that can simulate gravity. So for that situation, I have literally everything I'm going to need. And to start with, we have ChatGPT. I can just ask anything and quickly get an answer. And I have Unity documentation, which has a manual, which has, I think, some useful things. And I don't think these are that useful. Then we have this, which just has that project type that I can check out if it has anything that I could use. Maybe some scene building essentials I'll try to use to actually get the look fine. And then I have the Unity forums. So in this, I can actually ask someone if I can't solve anything, no matter how hard I try. And then we have the good old Brackeys video. And there's an ad, okay. Well, what I'm going to use this for is basically everything. And this is the formula that I'm going to use to simulate gravity. It's pretty simple. The gravitational force is equal to a gravitational constant multiplied by the mass of the first planet and the mass of the second planet multiplied together divided by the distance between the 2 planets squared. Now, how am I going to do this in Unity? I was doing well in terms of getting to know the interface of Unity. Adding shapes like the 2 spheres wasn't that much of a problem, as I had the documentation and the video to help me. But the actual issue is when it comes to scripting, which is what the gravity simulation is going to rely on a lot. And as you may know, I did Python for 2 years, not C#. So it's going to take a long time for me to get used to the syntax. Okay, so after a few hours of just figuring out how things work and how to do scripting, I have this scene here and we have two spheres. One is smaller than the other, and I have labeled the big one big planet and the small one small planet. And for each of these spheres, I have given them a script, and this script is essentially what applies the gravitational force to both of these spheres. And what I'm going to do now is, before I actually show you the simulation, I'm going to try to explain how this whole script works line by line, or more section by section. Now I would like to say that I didn't exactly only put the code that I saw in the video. I did include some things that I decided to add myself. But other than that, credit for this code goes to Brachis. So this section of code up here is basically me just declaring variables that I want to see in the inspector itself when I select a planet. For example, the rigid body slot, which is where I will add the rigid body component into so that I can manipulate the physics of the planet. And the position of the planet, whether it's collided with another planet or not, and the value of the gravitational constant, which is not actually 0.5, it's something much less, but for the sake of simplicity, I'm putting it as 0.5, and from the inspector itself, I can change it to whatever value I want. So next we have the actual function that applies a gravitational force to two planets, and it takes two parameters, which is the planet, the current planet that we are dealing with, and the next planet that we want to attract. So we have to start by first declaring a rigid body variable for the second planet as well, and we can do that the same way we would declare the rigid body of the first planet. Next we find the direction that we need to apply the force in, and that is done by subtracting the position of the target rigid body from the current rigid body. So to explain how exactly we get the direction vector, I have this scene here, and in which we have our two planets and a three-dimensional axis. To start, let's plot the two position vectors of these two planets. So now we have our two position vectors. Vector A goes from the origin to planet 1 and vector B goes from the origin to planet 2. Now these vectors represent the positions of planet 1 and 2. Now remember how we have to apply a force to planet 2 to attract it towards planet 1, as in that is going to be the gravitational force. So to do that, we need a vector that acts in the direction that goes from planet 2 to planet 1. And to do that, we can simply draw a vector that goes from planet 2 to planet 1 like this. And this vector, according to the triangle rule of vector addition, is simply going to be A minus B. Now remember how A and B represented the positions of the two planets? What A minus B is saying is the position of planet 1 minus the position of planet 2 will give us the direction vector that goes from planet 2 to planet 1. And now to find the distance between the two planets, we just need to take the magnitude of the direction vector, which we can do in this line. And then comes the calculation of the force magnitude. So the force magnitude is just the size of the force. It doesn't actually tell us where we apply the force. So how we do this is, we just take the formula and convert it into the notation that we have in C#, in which we have to involve the mass of the first planet multiplied by the mass of the second planet multiplied by a constant which is g divided by the distance between the two planets squared, or power to 2, which is what this function here does. Next, we actually have to convert this force magnitude into a force, which is a vector, and currently we only have a scalar quantity. So to do that, we declare vector 3 and name it force, and then we normalize the direction, which is basically converting the direction vector into a unit vector so that it's easier to use in other places as well, and then we multiply that unit vector by the force magnitude. And then the simplest thing to do is we add the attraction force to the target rigid body, which is the next planet, and that is basically done with the add force function, which is built into Unity. So now let's take a look at this function here. So what this function does is, it basically tells us when the two planets have collided, and we can do this by just starting to declare the function and using the onCollision enter, and for that we pass in two parameters, which is the class collision class and the next planet, which the current one is colliding with. So the first thing we do in this function is we first get the renderer of the planet, and the renderer is basically what controls the appearance of the planet. And if we then use an if statement to check if the renderer is present or not, and we can do that by saying renderer is not equal to null, and then if the two planets have collided, we set the color of the planet to red. So that's just a visual indicator that they have collided. And after that, I'm going to set that collided variable, the boolean, to true. Finally, let's take a look at our two update functions. So now these two functions do two different things, and there's a reason why I've done certain things in the fixed update function and certain things in the update function. The fixed update function, given its name, fixed, updates the scene at a specific time. So the time here is set to a default value, and that specific time frame that we update the scene is really good for physics calculations. Meanwhile, the void update function updates the scene every frame, and that's good for just general things like the position of the planet and the speed of the planet, which we need to know at every frame. Okay, let's take a look at our fixed update function. So what we do first is we get an array of all our planets, and we do this by finding objects of the type planet. Then we iterate over every planet in the array, and then we decide the conditions that we need to actually apply a gravitational force to it. So first of all, a planet can't apply a gravitational force to itself, and therefore we need to check if the planet is not equal to the current planet. And furthermore, once the planets have collided with something, we don't want them to continue applying the force. We just want the two planets to come to a stop when they collide. So we check if they have collided, and if they haven't, and if they are not the current planet, then only we apply the gravitational force. And now the void update function is much simpler. In this function, we just want to update a few things every frame, such as the position. So as you remember earlier, I declared the position as a label in the inspector in Unity. And now I'm updating that label every frame to show the position of the current planet. And furthermore, I'm also updating the speed, and I'm also showing that in the inspector. I added the speed label in the inspector much later though, so I didn't actually show it in the beginning, but it's self-explanatory. And now that we've gone through the whole script and we understand what each line does, we can just play the simulation and see what happens. So as you can see, the two planets are moving towards each other, and if you look at the inspector, the speed and position are changing until they collide and they turn red. And at that point, the collided variable is also switched to true. So now that we've established the basic things that happen in this simulation, this is going to be the end of the video. But in the next part, I will be adding more things like more functionality to the planets, textures, lighting. I'll be making this into a full-blown simulation of planets, and maybe even add some animations for explosions when they collide. Because right now, the whole thing is just looking a little bit blank. So I'll see you in the next video, and like and subscribe.